Introduction to Packet Tracer Software. Today we will introduce the Packet Tracer software. This is the latest version of Packet Tracer, and I am using version 6.2. Packet Tracer is a simulation software developed by Cisco Systems for CCNA certification, used for designing, configuring, and troubleshooting networks. Compared to the older BOSON software, Packet Tracer is more powerful in terms of functionality and consumes less memory. Let's take a look at the usage of several taskbars and toolbars. The first one is the Network Devices taskbar, where we can select the devices we need, such as routers, switches, and cables. The main screen is our workspace. In addition to this, at the top, we have the menu bar and toolbar. On the side, there is a selection tool, followed by an annotation tool, which allows us to add annotations to devices. For instance, we can select the device and add annotations, like switch 1 in the annotation bar. Next is the delete tool, which is also commonly used. For example, if we select a device and need to delete it, we can simply click on the delete icon, and the device will be removed. Moving on, there are several other tools, such as the test tool and view test tool, which together make up our Packet Tracer software. Now, let's talk about the commonly used save tool. To save our work, we go to the File menu and select Save. Packet Tracer files have the extension PKT. When saving, we can name the file based on the experiment. For instance, Experiment 1, and it will be saved as a PKT file. This is our brief introduction to Packet Tracer software. Next, we will proceed with a simple experiment. Alright, let's take a look. According to our lab manual, we need to select one switch and two PC machines. We will connect the switch and PC machines to test their communication. To do this, we will go to the Connections tab and select Cable bar. We will then connect one end to the PC's Fast Ethernet port, and the other end to the switch's Fast Ethernet 0 first port. Similarly, we will connect Fast Ethernet 0 first to the switch using Fast Ethernet 0 second. By doing this, we have set up the initial topology. Now, following the lab manual's instructions, we will configure the IP addresses for the PCS. Let's click on the first PC, and in the pop-up toolbar, choose Desktop, then IP configuration. We will configure the IP address as 192.168.1.2, subnet mask as 255.255.255.0, and gateway as 192.168.1.1. Now, let's close the configuration. Next, we will configure the second PC. Open the IP configuration and set the IP address as 192.168.1.3, with the gateway as 192.168.1.1. Close the configuration. Now, we have successfully configured the IP addresses and gateways for both PCS. One PC has an IP address of 192.168.1.2 with a gateway of 192.168.1.1, while the other PC has an IP address of 192.168.1.3 with a gateway of 192.168.1.1. 2.168.1.1. Due to the knowledge learned earlier, we know that these two PCS are in the same network. So, they should be able to communicate with each other through the switch. Let's test it. Go to the desktop, and then select Command Prompt. Type ping 192.168.1.3 and press Enter. As we can see, the test result shows that they can communicate successfully. 4 packets were sent and received without any loss. So, we have confirmed that PC0 and PC1 can communicate with each other. Next, let's test the communication between PC0, PC1, and their respective gateways. We will check the test result. And as expected, they cannot communicate. This is consistent with our lab manual because we have not set any gateway addresses, and the phenomenon mentioned above occurs. All right, that concludes the content of this lesson, where we learned about the Packet Tracer software. Please make sure to complete the lab exercises and familiarize yourselves with Packet Tracer's software following the instructions provided by me.